observing water flowing out of a tube, bottom of this container. See that water decreases, the water level decreases. Okay? And we timed it using somebody counting a pendulum and so forth. And we got a table that shows the water depth. Now this is in millimeters, it turns out, but you don't need to know that right now, versus clock time in ticks of the clock. So we get a table of water depth versus clock time. We make a graph of water depth versus clock time. Now, in making the graph, we pretty instinctively know that the less depth, the more slowly water is going to come out. So that the depth is going to change more and more slowly. And people have pretty good instinct. People answer pretty well that, okay, well, that means that the slope of the graph will be decreasing. Well, it's not really decreasing because it's negative and it's approaching zero, but it's getting less and less steep. So, okay, so the graph gets less and less steep. Now, when I ask people before we discuss this to sketch coordinates of these 3 points, which would be here, here, and here, and sketch a graph, okay, there were a couple of graphs that I saw. Mostly I saw either one like this orange graph here, or like the blue graph here. Now, one graph that I didn't see, and I'm glad I didn't, and it comes from people being taught to plot points and then make straight lines between the points. I don't know why anybody teaches people to do that, but there might be a reason. Maybe just have it. But so I drew a graph where we have straight line from here to here, straight line from here to here. Okay, and ask people which of these graphs is more realistic. Well, the steepness should decrease because as the water level decreases, water flows out more slowly, and the more slowly water flows out, the less steep this graph of depth versus clock time is going to be. Okay, I didn't label this. This is depth, and this is clock time. Okay, so the graph should get less and less steep, and that's what it does. Now, this curve doesn't work because the steepness is increasing right here, and that just isn't going to happen with water depth decreasing, because water depth is decreasing and the steepness is increasing. It doesn't make sense. Also, you don't have a sudden change in steepness. Okay? There's nothing about this data point here that would cause the rate at which water flows out to suddenly make a drastic change. And that's what happens with the green curve. So it's more or less the blue curve. And then we ask the question of what function do we have? What basic function do we have that would have a curve of this shape? And there are two possible answers. Okay, one is the left side of a parabola. This could be part of the left side of a parabola with a vertex occurring maybe somewhere around here. It hasn't completely leveled off, but it probably will soon. Or it could be like a 2 to the x function, reversed, so we have the 2 to the negative x function. Could be an exponential function. Now, the assumption we're going to make, because physics predicts it, and the assumption we're going to test is that a quadratic model works well. Okay? And we'll see how that works out.